Well, hello, friends. Welcome to this beautiful, or watch the recursive calls of the live stream starting here. Let's get into our final cram session here. And we're going to start with, that's not the PDF I want. There's the PDF I want. We're going to start with this 2020 exam samples questions. I have a link posted on Canvas where you found the link to this live stream. And let me check the live chats. How's everybody doing? Again, you can post any questions here. And I will take a look at the live chat. I didn't know this. You could pop out the live chat on YouTube. It's pretty fun. I'll make monitoring the chat just a bit easier. So let's take a look at the sample questions. I have not previewed these, so I'm going to go through these with you guys the first time. And I believe that they released this just after they made the announcement. This is the new format for this. Yeah, and there we go. It's the allotted time, 25 minutes plus 5 minutes to submit. So first question is going to be on arrays or array lists. And then the second question is going to be on using, let's see, where is it? Second question is going to be on using, second question is farther. There it is. Second question is going to be on using methods and control structures. Now the first one still is going to use methods and control structures, but it's going to be a little different. So I'm going to go ahead and pull up Notepad because to me that's going to be the easiest way to solve this. Just because I'm not going to get all the warnings and errors that you would likely get using an IDE. So I'm going to use that as my text editor because I'm fairly confident in my use of Java. Not entirely confident. There's always more to learn. But I'm fairly confident in my ability to use Java and know that my syntax is at least close. So let's take a look at this. Let's talk about strategies in going through this. And let's talk about how we can optimize our points in just that 25-minute window for this question. So I'm going to walk through it, answering the question using two strategies. Number one, optimizing my points first, and then number two, trying to actually solve the problem. And I'm going to answer it in kind of those two ways. And we will go through this. Okay. So direction, show all your work. Remember that your program segments are to be written in Java. Assume that classes listed in the quick Java reference have been imported. So array lists have been imported, math class has been imported, all that stuff has been imported. Unless otherwise noted in the question, assume that all parameters called are not null. Okay, so we don't have to deal with checking things are null. You would normally have to do that in production level code, but not in this case. Writing your solutions for each of question, you may use accessible methods that are listed, classes defined in the question. Writing significant amounts of code that can be replaced by a call of one of the other methods will not receive full credit. Don't try to rewrite what's already there. Use the tools that are given to you. Here's a question. The Gizmo class represents gadgets that people purchase. Some Gizmo objects are electronic and others are not. A partial definition of a Gizmo class is shown below. So public class Gizmo returns the manufacturer of the Gizmo. So we have our getters here, returns true. So most likely we're going to need these, right? We're going to need to call getMaker at some point. We're going to need to call isElectronic, and we're going to need to call our equals method. Remember, this equals method actually overrides our object that's inherited from object automatically. So let's read these. The second one here returns true if a gizmo is electronic and false otherwise. And our equals set checks if these two objects are equal. So we're going to be doing some kind of comparison here. Okay. The online purchasing manager, trying to make this real life here, that we're building an online purchasing manager. Class manages a sequence of gizmo objects that an individual has purchased from an online vendor. You will write two methods, the online purchase manager class of the online purchase manager class, and a partial definition of the online purchase manager class is stated below. So here we have things that we already have. So we already have an array list of purchases. So we already have that available to us. That's great. And we already have a new couple of methods. So here's our part A method and here's our part B method. So our part A method returns the number of purchase gizmos objects that are electronic and are manufactured by a specific maker that's passed in as a parameter here. And that's to be implemented in part A. So let's go ahead and take a look at part A. Part A, write an electronic count electronics by maker method. The method examines the array list instance variables purchases to determine how many gizmo objects purchased are electronic and are manufactured by the maker. Assume that online purchase manager object OPM has been declared and initialize that the array list purchases contains gizmo objects that are represented in the following table. Okay, so these are the objects. This is our test data that we would have. The following table shows the value returned by some calls of count electronic by makers. So this is giving you test cases. This is amazing. So you can trace your problem and your solution and make sure that it matches this. We didn't get this in other AP questions. So you have to do your own manual tracing, but you can do a quick tracing. I highly suggest, if this is how they're going to do the question, get a piece of paper, have several pieces of blank paper, and once you write your solution, trace it to make sure you match these outputs. That's fantastic. That's going to give you guys a huge leg up on being able to make sure that you're able to solve these problems. Okay, so that's part A. We need to create our count electronics by maker. So let's double check our count electronics by maker. It's not static. Okay, so we don't have to worry about static or anything in that. We do need to return an integer. Okay, so we need to make sure that we do that. So let's practice writing. Let's say we have no idea how to solve this problem. We're just going to write this in terms of maximizing points without an idea of how to solve it. So public int count electronic maker, and that's going to take in a string, and we're going to call that maker. There we go. And let me just double check that the stream, it looks like it's working much better today. I downgraded the stream to 720 in hopes that we have less buffering issues. Hopefully it's good enough to be able to see what's actually going on here. Okay, back to the question. Super on the chat, how are we doing? Anyone, any questions? Doesn't look like it so far. Okay, so wrong one. There it is, acorn. Okay, so here we go. Let's maximize points. Let's look at the question again and see where we're going to be using points. How can we get points? Okay, array list. Array lists are pretty much only used when you need to loop through an entire list. We're not looking for specific locations. So we know we're going to need to write a for loop. Since this is an array list, a for each loop is going to save us characters and save us time. So we can say for what? What kind of object is being saved in there? A gizmo object. So for gizmo, we'll call it giz. Okay, inside of our purchases array list, so inside of purchases, okay, we're going to have a loop. And this is where I miss my IDE because I don't have ways to quickly tab things. Just going to use 3 spaces. Okay, so I've got my loop. I can almost guarantee you that is a free point right there. Okay, so then we need to check something. We know that we're going to need to count, right? Anytime we know that it says it asks for a count of something, we're going to create a count. So again, I have no idea how I'm going to solve this yet. I know that I'm going to need int count, and I'm going to call it equal to 0 to start. Still have no idea how to solve this, and I'm going to return count. Okay, free point, done. All right. Now, let's talk about how to solve the problem. Well, I have a parameter. I'm going to need to use that parameter at some point, and I'm going to need to check if it is electronic. So I'm going to say if giz.isElectronic okay, so if giz is electronic, and let's make sure we have those parameters. There's no parameters. We're just going to call public boolean is electronic. So if giz is electronic, and what else? What else does it need to do? We need to have our string of our maker, our getMaker method, equal to the maker that's passed in. So we're going to say giz.getMaker, and remember this is going to return a string for us. So getMaker, and what do we need to do? We need to use our string of methods that are available. Let me jump into Canvas really quick here. Oops, this is my video game design class. And let me pull up our available methods. And I should have had this up earlier. I apologize for the delay here. We got 2 hours and 46 minutes till the exam. And I'm going to do AP exam materials. Testable methods. Oh, I actually already have that open. Well, that's all right. We'll have 2 copies. There we go. So back to our strings. We're going to use dot equals. Returns true if this is equal to our other. So getMaker is a string. We're going to say dot equals maker. Then what are we going to do? We're going to increment count. Boom. Done. We can run our trace if we need to, but again, we're talking about maximizing points here. So I wouldn't run traces until you've answered all parts of a question. Then you can go on to answer the next part. Okay, so this is part A. And we really want to clearly mark this for our graders. So this is part A. And part B. When purchasing items online, users occasionally purchase 2 identical items in rapid succession without intending to do so. Example, by clicking a purchase button twice. A vendor may want to check a user's purchase history to detect which occurrences and request confirmation. Write a has adjacent equal pair. And actually, before I move on, any questions, Abbas? If we're writing a txt file, yes, put your name and ID at the top. So any file you're going to submit, you're going to put your name and ID at the top. So I'm going to put here Webster, and then I'm going to put my ID of, and I'll use a pipe. I'll put my ID of 1, 2, 3, 4, 5, 6. Okay, so that is up at the top of the file. Make sure you have it there. I don't believe they are accepting .java files, but I'm not sure. You can, if you're using an IDE, you can convert it to a TXT file. Make sure you know how to do that if you are going to do it that way. Write a has adjacent equal pair method. The method detects whether two adjacent gizmo objects in purchases are equivalent using the equals method of the gizmo class. If an adjacent equivalent pair is found, the has adjacent equal pair method returns true. If no such pair is found, or if the purchases has fewer than two elements, the method returns false. Okay, so we're going to kind of go backwards through this. And if the purchases has fewer than two elements, return false. So we can first write our class definition. Public Boolean has adjacent equal pair. And we're first going to what? We're going to hit a simple return statement, right? Just in case. We can always change this later, but just in case, let's put a simple return statement there. We know free points right here. Or if purchases has fewer than two elements, returns false. Even though it's written at the end of the question, we know that that's going to be our first thing. So actually, we can write right here, if what? If our purchases array dot size is less than 2, go ahead and return false. Boom, done. We just got a free point. Let's look for the rest of this. So again, thinking in terms of free points, if an adjacent or equivalent pair is found that has adjacent equal returns true. So we know that this is going to return false here. So at some point we're going to need a return true. Okay, and how can we get to this return true? Well, if an adjacent or equivalent pair, adjacent pairs means we're going to need a loop. So for, and what kind of loop? Well, we're checking at specific indices. So we're going to have to use a traditional for loop because our for each loop that we used before can't check items right next to each other. So we're going to say for int I equal to 0. And we're going to say I less than purchases. If I can spell purchases. Dot size. And we're going to say I plus plus. Okay. And we're going to wrap this return true in here. Okay. So again, free point. Looping through with no issues. We saw that in the grading scale before, that there's going to be looping through purchases. Free point most likely in this question. It returns true, but when does it return true? It only returns true if something happens, if there's an adjacent equivalent pair found. So we're going to say we need to loop through this, and we're going to say if our current index is the same as our previous index. Now, remember, whenever we do these kinds of comparisons, we have to be careful about index out of bounds exceptions because we're going from the very beginning to the very end. The way we can do this and solve this real quickly is set this equal to 1, and instead of checking forward, we check backwards, okay? And we don't have to worry about an index out of bounds exception here because we've already checked for 2 in the beginning. So if our current index, so if purchases dot get I dot equals purchases dot get whoops, I minus 1. So if purchases equals our I minus 1. Let's double check that with our methods here. Our array list methods. Yep, so there's our get, right? We made sure we got the correct syntax for that. Let's double check our syntax for our equals. Our dot equals, we're passing in this object that we had before. Yes, it's good, so that should work. Last thing we need to do for part B is return false. So if it makes it through all of these tests, if it doesn't return true, it's going to return false down here, and we get our answer. Let's check chat. Any other questions so far? Feel free to put them in the chat. I will stay here as long as we need, answer as many questions as I can. Part C. A programmer would like to add a method getCheapestGizmo by maker, which returns the least expensive gizmo purchased by an individual from a given maker. Write a description of how you would change the gizmo and online purchase manager classes in order to support this modification. Make sure to indicate the following in your response. Write a method header for getCheapestGizmo by maker method. Identify any new or modified variables, constants, or constructors methods methods aside from the cheapest maker method. Do not write the program code for this change. Describe for each new or revised variable, constant, constructor, or method how it would change or be implemented, including visibility and type. You do not need to describe the getCheapestGizmo by maker method. Do not write the program code for this change. Okay. So a more detailed question I often asked in my open-ended questions. So unfortunately, I didn't quite nail that, but that's okay. We can still answer this. We're smart. We can do this. At least we pretend to be smart. A programmer would like to add a method getCheapestGizmo by maker. Okay, so the things we really want to focus on when we're answering this question are those 3 bullet points. Those are where our points are going to come from, is each of these. So think of these like a rubric. So write the method header for getCheapestGizmo. We know how to do that. We're going to write public, and we're probably going to want to return what? We're going to want to return the maker, right? So we're going to want to return a string. So public string, because it's asking for the maker, public string get cheapest gizmo by maker. Okay, that is the first bullet point. And then maybe a couple curly brackets. Identify any new or modified variables, constants, constructors, or methods aside from the getCheapestGizmo by maker. Well, what's something we haven't seen so far? We're going to need... So the gizmo class will need to hold a private price variable in order to compare the price or prices of gizmos purchased. Okay, so that gives us our first thing that we need to, our first bullet point. You might want to elaborate on that more, maybe not. Again, I would keep it short, to the point, answer the question. Don't go on too much. Describe for each new revised variable, constant, constructor, or method how it would change or be implemented, including visibility and type. So would hold a private double in order to compare the prices of gizmos purchased. The price variable will be initialized in a new constructor. Oops, we'll say new constructor that will set the price. The gizmo class will also need what? It's also going to need a get price method. That will return the price of the gizmo. Need a public get price method. That's how I would answer this question, making sure that I hit all three of these to try to get maximum points while also keeping it short and keeping an eye on the time. Okay, let's see, how long did it take me to do that? 28 minutes. I did add extra time because I'm trying to explain things here, but that's about the pace that we want to answer things. Check if there's any questions in the chat. You could say, yeah, we could say return gizmo. Yeah, boss, we could say return gizmo. So we could say public gizmo here. And that's probably what they are looking for. Because it is saying get the cheapest gizmo, but by maker, yeah, is the parameter. And we're going to have a parameter inside of here, right? So we actually do need to add our parameter, string maker, inside of here. Good call on that, boss. So public gizmo, get cheapest gizmo by maker, and we're going to need to take in our maker. All right, let's take a look at the next one. Here's a question. Do they have a scoring guide at the end? No, they don't. Okay. Let's take a look at question 2. This is the faster question. Same notes at the top about not worrying about null or anything else. So when you are writing this and you're submitting this for the AP exam, you're going to submit question 1, and then you would start a new document for question 2, but I'll go ahead and leave this document here so we can start on question 2. So only 15 minutes. This is a quick question, relatively speaking. The question involves the use of check digits, which can be used to help detect if an error has occurred when a number is entered or transmitted electronically. The check digit class is shown below. Check digit returns check digit for num. Precondition: the number of digits in num is between 1 and 6 inclusive. So num is greater than 0. Greater than or equal to 0. Why are they showing greater than or equal to 0? Number of digits in between 1 and 6 inclusive. Public static get check int num. Implementation not shown. Okay. And returns true. The last one returns true if num with check digit is valid or false otherwise, as described in part A. Boy, their formatting is even worse than mine. It's all over the place. Precondition: the number of digits in num with check digit is between 2 and 7 inclusive. Num with check digit is greater than or equal to 0. Public static boolean is valid. Should be implemented in part A. Okay, returns the check digit for num. So get check. And then we have num with check digit. Let me read this. This is a weird question. Question involves use of check digits, which can be used to help detect if an error has occurred when a number is entered or transmitted electronically. Part A, write a is valid method. The method returns true if its parameter num with check digit, which represents the number containing a check digit, is valid, and false otherwise. The check digit is always the rightmost digit of num with check digit. The following table shows examples of use of is valid. So check digit 159, return value of 2. Check digit for 159 is 2. Is valid of 1592 is true. The number 159 is valid, combination of a number 159 and its check digit 2. Is valid 1593 is false. Is not valid, combination of 159 and its check digit 3, because 2 is the check digit for 159. Complete the method is valid below. You must use get check appropriately. So we know we're going to have to call this method at some point. Free points here. I have no idea what this is yet. Returns true if num with check digit is valid, or false otherwise as described in part A. Precondition: the number of digits in num with check digit is between 2 and 7 inclusive. Public static boolean is valid. Okay. Public static boolean is valid. Int num with check digit. Okay, so again, I have no idea how I'm going to solve this yet. I'm still not quite sure how the check digit works. So we will work on this. So is valid. We're going to first, we know we need to call get check digit. These are all, if we look closely, these are all static methods. So we're going to be passing in these parameters on our methods. So we know we're going to need to say get check and we're going to get check on our num with check digit. So we're going to need to get our check, and we're going to want to save that check, right? We don't just need it somewhere, so we'll say int, we'll call it check equals get check. Boom, free point. Okay, what else do we need to call? Returns true if num with check digit is valid, otherwise false. So int check, and we're going to see if it has a num with check digit. So this is our public. We only have the one get check here. And our check digit is is valid and returns true if the parameter which represents a number containing a check is false. Otherwise, the check digit is always the rightmost digit. Okay, so it's the very last digit of this. Okay, so our check digit is going to be our rightmost digit, which means we need to do a check of everything to the left of it. Okay, so how do we get the leftmost digit? We have to think in terms of base 10 numbers here. Yeah, so it looks like every natural number has a check digit. So in this case, we're thinking of 159, but we're going to be passed in the number 1592, right? And we don't know how check digit is really created. This is one of those tricky things where we have to think abstractly. We have to think about the black box. Okay, so we're going to want to check the left, the characters to the left. So let's just type here again. The test case was 1592, right? So we need to pass into this our get check of 159. So how do we lop off that 2? Well, we lop off that 2 by getting 159, and the way we can do that mathematically is dividing this by 10 in integer math. So if we divide this by 10 in integer math, it won't destroy this data here. This data will stay the same. It's just going to evaluate what this integer math is and get our checksum of 159. Okay, so our integer value is there and our check is created. So now we need to check our check against the value, the parameter that's passed in, and we need to lop off that last digit. Again, how do we do this? We've done this. We did that in the digit sum. If you remember that, if you recall that from, I believe it was last semester, we created that method that would count up all of the sum of a digits in an integer. We used modulus. So our friend modulus is going to come into play here. So we're going to say if our number that comes in equals our check. So if our num with check digit, and we want to lop off the last bit. So we want to lop off that ending number, in this case right here. So we're going to modulus 10 to lop off that last number. If that equals our check, then we're going to return true. And otherwise, we're going to return false. And I didn't do this. I should have written a return false first because I wasn't sure how I was going to answer it, and I was going to try to get free points. And then it becomes our free response question. A programmer wants to modify the check digit class to keep track of how many times a call is made with an incorrect check digit. At any time a call an is valid is made with an incorrect check digit, the count should be increased by 1. The Cram programmer would like to implement this change without making any changes to the signature of is valid method or overloading is valid. Write a description of how you would change the check digit class in order to support this modification. Do not write the program code for this change. Make sure to include the following in your response. Identify any new or modified variables, constants, or methods. Describe for each new revised variable constant method how it would change or be implemented, including visibility and type. So here we go for B. Come on, stop messing around with me. Okay, so for B, we're going to want to, again, hit those 2 bullet points. What are we going to need to do? Right now, if we remember, we're in static. Anytime we're in static, we're going to have to stay static. And the programmer doesn't want to change any of this. So how would we implement a static variable in order to deal with this? And this is actually a pretty complicated question here. Any ideas? You guys want to throw them out in the comments in the live stream here? How would you guys maybe answer this? I'll give you a moment here. Think about this. How would you answer this question? Make sure our live stream is still running smoothly. Looks like it is. Got 6 of you watching. Woo! And 8 whole subscribers. Wow. I feel popular. Good, boss. I like your answer there. A new private static instance field. And good to call it an instance field that stores an integer. Created the count of how many incorrect or valid calls. Yes, I watched Lockdown Math with 3 Blue, 1 Brown. We could probably actually... Oh, it streamed 2 days ago. But yes, I like 3 Blue, 1 Brown. I'm a huge fan of 3 Blue, 1 Brown. He's incredibly smart. I wish I could be half as smart as he is. Okay, let's get back to the question here. So, Abbas is pretty much on track. So we would create a new private static instance variable. If I can spell variable. I don't know, we'll call it count that is incremented with the is valid. Incremented when, not with, but when the is valid method returns false. There would also need to be a public static get invalid count method that returns the count variable. So that way we have access to it. So let's take a look at the scoring guide for the open-ended questions. A single paragraph, 2 to 4 sentences, again, not very long, may be sufficient for answering these questions. The provided bullets in the question are meant to guide your single paragraph response. It is not necessary to provide a separate response for each bullet, but we want to make sure that we're hitting each bullet as we go through. The following verbs, in addition to the task verbs in free response question, exam description. Let's see, this is a link. We'll follow that in just a second. Identify. So you're going to want to make sure you're identified, right? So creating a new private, that's identification right there. Provide a name for a specific addition or modification as it relates to the problem without elaboration or explanation. For example, I need a new variable to represent the item that appears the greatest number of times in the list. So you don't even have to create this, but you need to say what it is. Describe. Provide the relevant features or characteristics, including any visibility or type of your proposed modification. For example, I need a new instance variable, which will be a new private static string object in the sample class representing the item that appears the greatest number of times in the list. The example includes identification and a description necessary for this specific addition. That returns false. So we're going to want to add here and keeps track of the number of non-valid checks. Right, something like that. So we're describing what it is and how it's being used, and we're identifying it clearly so that we know what it is that we want to do. Let's take a look at this exam. Oh, this is the full 200-page PDF here. So I had mentioned it in many of my free response discussion pages about what you want to do. And there's computational thinking. I think it's just past here. No, these are the unit descriptions. Yada, yada, yada. These are units at a glance. No, unit guides. Okay. It's back here. I know it is. So all of the questions that are going to be on the AP exam are 3A through 3D. Out of all of the standards that we were supposed to hit this semester, these are the only ones that we have. Write program code to identify a new type of creating classes, satisfy method specifications, and either a 1D array or array list. All the other stuff we don't have to worry about. It's kind of beautiful. We only have to worry about these 4 standards right here. Computational thinking and practices, framework components, and I've lost it. It's somewhere in here. I'm not going to spend this whole time looking through all 200 pages of this. Okay, any questions so far on how we've answered this? Rita, okay, so I explained at the beginning of this video, and I'll go a little bit more into it about why I'm using Notepad in this case. Part of the reason that I'm using Notepad is, number one, it's already in TXT, which I know they're going to accept right away. I don't have to do any futzing with trying to convert the file into something that they can accept, because it looks like from their documentation they're not accepting .java files. The other reason is that, yes, a code editor can help, and you're welcome to use them. But for me, because we're using all of these extra classes and things that we haven't defined, and we're calling methods that we're not going to have access to in our code editors, we're going to get all kinds of errors in our IDE, especially if you're using something like IntelliJ or Eclipse. Even BlueJ is going to start yelling at you and giving you all kinds of warnings and red lines, and you aren't going to be able to see the real errors versus the errors that are manufactured because you don't have a, say, isElectronic method already written. And you're not going to have time to write all that stuff out unless you can type it like 200 words a minute and you can create and implement and do all this stuff really quick. You're not going to have time to do that. If you can write that fast, go for it. But you're going to have to create multiple classes for the question 1. And it's just going to be, for me personally, I think it's going to be easier to just write it in Notepad or a very simple editor. You can use Notepad++. We haven't really talked about that in this class. Or you can use something lightweight like VS Code, Visual Studio Code. Something that's not going to give you too many errors, that's not looking too closely at your Java, but maybe is giving you a couple of hints here and there that maybe you missed a semicolon or something like that. But Notepad is just straightforward. You can't really screw it up too much. The only thing you have to be wary about is that you don't have tabs, so you're going to have to hit space a few times, but not really a big deal. It doesn't slow you down all that much. And I think it, again, for me, it keeps it clean, it keeps it easy, and I don't have to worry too much about what's going to happen in terms of errors and accidental editing, because I'm trying to correct for an error that isn't really an error. So I guess I didn't really answer the question. I just said for me, yeah, I think it's beneficial to write on Notepad Rita. You know, we've been taking our tests on paper so much, you guys should be pretty comfortable with being able to write code on a blank piece of paper. I hope you are at this point. And again, I think it declutters, and you're not going to get errors for, like, here, I have 2 C's on public. They're not, they know what you mean, right? And getting rid of a lot of the small errors, yes, it's helpful. Yes, it makes you look better, but the grading is so consistent in APCSA. It's the most consistently graded AP that those kinds of small errors are not going to really affect you as much as they would in some other AP exam, right? APCSA is much more about intent than it is absolute answers. Say, for example, in AP Calculus, if you mess up a negative here or there, you can get massive points off because it may not be clear that you understood the question. Whereas here, if I accidentally put a C on the end of public, similar type of small error, I won't get many points off because it's very clear that I understand that this needs to be a public Boolean. So yes, I think Notepad is probably the way to go. That's the way that I would go in answering this. Or you could use like a Google Docs or something else if you want to be able to use Tab a little bit faster. You could use Microsoft Word and do that as well. Notepad's just light and fast, and it's already in the fun mono-spaced font, so it feels kind of like you're coding already. So that's where I would go with that. How's the live stream today, by the way, everyone? Is it more stable? It feels like it's more stable. I've tweaked some settings in OBS. Hopefully it's going to stick around for a little bit here. Awesome. That's good news. It only took me till the very last review session to actually get a decent live stream here, so I apologize. I am learning just like you guys, just learning slightly different stuff. Well, unless there's any other questions. Oh, we got a fun recursive call. Here it is. This is actually my favorite thing. When I was a kid, just a side story really quick. When I was a kid, my dad had a recording studio, and he had some video equipment. And one of my favorite things was to hook up a TV monitor with the camera and point the camera straight at the TV, and you would get this long tunnel effect, just like we had earlier in kind of that recursive call, but it is a mechanical, not a digital recursive call. Kind of a fun thing. Well, the one unfortunate thing with CodingBat is CodingBat doesn't have array list practice problems. But we can just work through some of these problems and we can start to warm up a little bit. So if you're following along, put this on half screen maybe, and let's go to codingbat.java. We'll go to the array 3 area, and we'll go ahead and try one of these. Let's just go with the first one. Let's go max span. So take a moment. I'm going to sit here for a second and see if you can answer this question. I got to go run really quick. I'll be back in just a moment. See if you can answer this. Max span, it's problem number 189576 on CodingBat. I've done enough talking and enough of this. Now you guys need to start getting active as we get closer to the exam. You need to start getting this into your fingers. So I'll be back in just a few moments. All right, I am back. Okay. Got my snack. Hopefully my chewing isn't too annoying. So consider the leftmost and rightmost appearances of some value in an array. We'll say that the span is the number of elements between the two inclusive. A single value has a span of 1. Returns the largest span found in the given array. Efficiency is not a priority. The leftmost and rightmost appearances of some value. So we're looking for any repetition of a value. This is our classic searching algorithm. It's almost like a sorting algorithm. So what we're going to need is we're going to need something that loops through, finds a value, and then looks for that value somewhere else in the array. So what can we do here? We're going to need 2 loops. We're going to need to take a value, and then we're going to need to look for that value again in the array, starting from its leftmost value and checking for the rightmost value. Now, we can do some things to make this more efficient, but again, efficiency doesn't really matter. So we can do multiple checks. Okay, so we're not worried about trying to get rid of multiple checks. We're just going to find a value and then search through the rest of the array and find the farthest away value that we can. It's going to take 2 loops. And we know that this is going to be an integer array. So our loops are going to be in integers, but we can't use for each loops. I was thinking about using that earlier, but we can't. We're going to need to keep track of indices and keep track of numbers. So first thing we're going to want to do is we're going to want to track the distance. So int, and we'll call it distance, D-I-S-T. And we'll call that 0 is our initial distance. And we're going to be comparing against that initial distance coming up. So for our int I, and we'll set that equal to 0 to start. And we're going to say I is less than, if we're going to check from right to left, we're going to make sure that we don't accidentally go over the end of our array, but actually we can control that in our second one. So we can say our nums dot length here, and we're going to say I plus plus. Okay, so now that we have this, we're going to pull out our first piece of data. So we're going to say our first piece of data is going to be nums at I. And what do we want to compare nums at I to? We're going to want to compare nums at I to another position, say a nums at j, right? So nums at j, we're going to have to search through. So we created nums at I, it's going to start here, and then it's going to have to look through the rest of all of these things here to find our new distance. So we're going to need another for loop to search through with j. So for int, oops, we need a parentheses there, for int j equals to what? It's going to start at I, because we don't need to go back. We just need to start where I is. And we can actually say I plus 1. Actually, I'm not going to say I plus 1 for a reason. So int I plus 1 and j less than nums dot length. Okay. So the reason I'm not saying j equals I plus 1, yes, we could save one cycle by saying I plus 1. However, we would run into an index out of bounds exception with our nums less than I less than length here. So that's why I'm not putting I plus 1. Less efficient, yes. Protects us from index out of bounds exception, which is really what we care about. We don't want our, if it means one more cycle and our code doesn't break, I'm going to take the one more cycle over breaking code. Okay, so now nums I needs to go in here. So we're going to say nums I. And what do we need to check? We need to check and see if it's the same value. So we need to see if 1 is 1 here. So that's going to be our check. So our if statement is if nums I double equals nums at j. So if these two things are equal, then what do we do? Well, we need to find the distance between them. What is the distance? The distance is going to be j minus I. So if this is true, then what are we going to do? Then we're going to need to do another check. Whoops, I have two i's here. So if nums I equals nums j, then we're going to do another check. If j minus I is greater than 1, our distance, then we need to set our distance to j minus I. And that should, emphasis on should, work. I have a compile time error. What do I have? What did I mess up? Line 11, missing return. Oh, we need to return it. Always, return statements. My nemesis. Return distance. There we go. Let's see how we did. All failed. Why? 4, 5. So I have an off by 1 error here. What is my off by 1 error? 2, and that is index 3. So this has index 3, 1, 2, 3, 4. A single value has a span of 1. So we can do this simply by saying +1 here. And that should almost fix it. One, 2, 3, 4. And why am I getting 3? I'm getting 0. I mean 1, 2, 3. 0, 1, 2, 3 minus 0 should give me 3 plus 1. Why am I still getting 3 on that? Oh, we need to do our +1 here as well. There we go. So I missed the single value span of 1. And that gets us our answer, an off by 1 error there. Those are my least favorite kinds of errors, the off by 1 errors. So far, the way that I've read a lot of these AP questions, they're not quite like the coding back questions. They don't have those tricky off by 1 issues. Sometimes they do, but for the most part, they're pretty straightforward. Let's go to our next array one. Fix 3, 4. Take a couple minutes, take a look at this, and see how you're doing. How many people do we have? There's 5 of you. This will be our last practice as a group today. If you have any questions, get them in now. I'm happy to review other things. But it's also important to do some personal time review. I'll give you another minute or so to keep working on this problem, then we'll jump into it as a group. All right, so let's go ahead and give this a shot. So we have an array. We're going to take in that array, and then we're going to modify the array to put something in. So we're going to need our swap algorithm. Remember, our swap algorithm is going to need 3 pieces of data. So we're going to need a temp. So we're going to need an int temp value. And we're going to need to loop through this probably twice again. So we're going to loop through once, find 3s. Once we find a 3, we're going to need to loop through and find a 4. But we want to make sure that we're not accidentally moving things that we don't want to move again. Now, one thing that they don't specify in this is, are all of the 4s after 3s already? Oh, and a 3 appears in the array before any 4. This is key right here. So this solves a big problem for us. So we know that we're going to do essentially what we just did in the last one, where we're going to do multiple loops. So we're going to need nested loops again. So for int I equals 0, I is less than nums dot length, and we're going to say I plus plus, and immediately I'm just going to go ahead and say for int j equal to I, j less than nums dot length, and j plus plus. Okay, so here we go. We have our nested loops. We're going to have our outer loop working one at a time, and our inner loop is going to run through and keep searching the array. Now, I may need to change this right here. Okay, so this may need to change, and the reason I'm thinking that this may need to change is once I find a 4, I don't necessarily want to start at that position again. I can actually start a little bit farther ahead, but again, efficiency is not huge here. Because once I find a 3, I know the next number is a 4, and then we can search for 4s again. All right, so let's see here. Our inner loop here. What are we going to want to do? We're first going to want to say we're going to first want to find our 3. So if nums at I double equals 3. And now that I think about it, we can actually move this into an outer loop and be a little bit more efficient. We can force this inner loop to look for 4s only if our current number is a 3. So if our current number is a 3, then we're going to search. Otherwise, don't run the inner loop. So we can do this. So if nums at I double equals 3, then we're going to want to search for 4s. So then we're going to say if nums at j, so if nums at j double equals 4, Then we're going to need to swap. So if nums at j equals 4, we need to do our swapping algorithm. And what are we going to need to swap? We're going to need to swap the number directly after 3, so I plus 1, with whatever j is sitting at. And we want to save what is at I plus 1. So we're going to say temp. We need to save that value first. So temp equals nums at I plus 1 and then we're going to put our 4 into that nums at I plus 1. So we're going to say nums at I plus 1 equals 4. And then we're going to put the number that we saved in temp where we found that 4. So nums at j equals temp. So there we've swapped out those two things. We first took out the number that we don't want to destroy. We set that position to 4, and then we took our temp number and put it into where we found that 4 before. Now, one thing we can do to make sure that we don't accidentally move the wrong 4, or in this case, you see that there's a 4 in front of this 3. This algorithm won't check that, right? Because our I here is where this 3 is, and it's going to check the rest of this array. So it actually has to be able to go back and find the previous value. So we're going to create a new int here, and we're going to call this last 4. Okay, and our last 4 is going to start at where? Well, it's going to start at 0. And this might cause a little problem in the beginning, as be a little less efficient, but it won't be a huge deal. So we're going to call this last 4. And when it starts at last 4, when we find a 4, we're going to say last 4 equals j. So now it will always start wherever it found the last 4, and it will keep moving forward from there. So that if a 4 is in front of a 3, it won't accidentally skip over that 4 and read something else. Let's see how I did. I probably have an error somewhere. Oops, did I forget a return? Oh, I need to spell length right. Missing a return statement, line 16. So, we need to return nums. See how we did. Oh, we missed 1. Aha. Okay, let's take a look at this test case. So what do I have off? 3, 4. So I didn't catch this 4 here. Interesting. Why? Probably another off by 1 error here. I plus 1. So you're able to switch that. And it found that 4 and swapped those. Good. Then it started here. I swapped these two. It started here and it went to here and it searched through to 3 here. And it should have gone back and found this 4, but it did not. Why did it skip over that 4? That's really weird. Still getting the same. On this. So we're going to do a quick trace here. I'm going to pull up my notepad again. So our quick trace. We're going to have temp. We're going to have last 4, which equals 0. And we're going to have I, which starts at 0. We're going to have J, which starts at 0. All right, and our array that we're going is 5, 3, 5, 4, 5, 4, 5, 4, 3, 5, 3, 5. So when we first start through, it's going to loop through I at 0. It's not going to be equal to 3, so it's going to skip all this. I will become 1. So I is now 1. It's going to loop inside, and it's going to find the next one. I at 1 is now 3. So this is now going to go. It's going to start at 0, and it's going to search through, and it's going to loop through. First pass, it will fail. Second pass, this will fail. Third pass, so this is now 2. This will fail. And now J is 3. And we find a 4. This will pass. This returns true. Temp equals nums I plus 1. So temp is going to be I plus 1. I is number 1 plus 1 will give me index 2. So temp is now 5. Nums equal of I plus 1 will now equal 4. So we're going to put a 4 there. And nums at j equals temp. So nums at j, and j is currently 3, so 0, 1, 2, 3. This will equal temp, which is 5. Last 4 equals j. J is currently 3. And we move on. Dump out of this loop, and we're going to search through I again. We found here, we're going to go 1, 2. So I becomes 2. I becomes 3. I becomes 4. I becomes 5. I becomes 6. I becomes 7. So I is at 7 here. Is that right? 1, 2, 3, 4, 5, 6, 7. If it's at 9, 1, 2, 3, 4, 5, 6, 7, 8. So it's actually I should be 8 now. Okay, I is now 8. I is 3, which is correct. For int j, j starts at 3. So j starts at 1, 2, 3 here. J is, it's going to loop through now. So we're going to check j at 4, and that fails. Check j at 5, and that fails. Check j at 6. That should pass. J at 6 should equal 4. Let's make 1, 2, 3, 4, 5. Sorry, J at 5. Oops, that was 5. J at 5. So J at 5 should be this, and we should get what? So J at 5 is 4. Okay, so then we're going to take I plus 1, which is a 5 here. So I is 8, so temp will be 5 again. And we will do our swap algorithm. So temp now is 5. Nums at I equals 4. So this should equal 4 here. And then we're going to put in temp here. And then we're going to set last 4 equal to j, which should give us 5. I am not seeing where my error is. It's 4, it's 4, 5. Okay, so let's look through here. This 4 is in front of the 3, and it's able to get that. This 4 is after the 3. These two 4s are after the 3s, but moves them forward. These 4s are also after the 3s and moves them forward. That one works. And the last one works. But it's not able to solve it for the middle one. Why? Let's try doing j plus 1. Yeah, no, it shouldn't be j plus 1. That's not. But what is changing in our... So here we move the 4 over. J minus 1 doesn't change it. So it's not an issue with that. probably get an index out of bounds error if I do this. No. It solves this one. J minus 2. So what's going on? Any ideas? Anyone catch my mistake yet? Is anyone still with me? You guys totally bored? J minus 2 has an error where these two should be switched. So I'm looping through. I find this. And I'm able to get the second one, but not the first one. So when I equals 3, then we need to look for 4s. We could do this backwards. We could look for 4s because we know they're always in matching pairs, but I feel like we're so close. Last 4 should not equal I. And if we just set j equal to 0 each time, we're going to find the same 4. We're going to find the first 4 in the list. So we need to not do that. We could do this. No, because we can't say 3i plus 1. So if we say I plus 1, then we're always searching after the 3s. And sometimes the 4s are in front of the 3s. So we can't say I plus 1. So minus 2 gets us an error on the first one. Last 4 equal to j gets us an error on this one. And I am still failing to see it, and I don't have a way to trace. To trace this. I'm going to have to get out a piece of paper and trace it by hand. Let's see here. All of my pencils are falling apart. I have to do this with a pen. Okay. So 4, we're going to have temp. Now I just need to do this for myself. We're going to have last 4. I'm going to have my I, my j, and we have the array. And let's me write down this array here again. 5. I'm sorry you can't see what I'm doing here. 4, 5, 4. So then on my first run, nums I does not equal 3, so then I increment I to 1, and that will get me a true statement. So then I step inside. J is going to equal 0. And then I am going to go ahead and loop inside there. And starting at 0, I'm going to check for all of my instances in the array. At 0, it doesn't find a 4. At 1, it doesn't find a 4. At 5, at 2, it doesn't find a 4. And at 3, it does find a 4. So then I am going to save into temp, my I plus 1. I is at 1, so temp is going to say 5. And then I'm going to put into that position 4. And I'm going to go ahead and put last 4 is equal to 3. And lastly, I'm going to change my position at J. I'm going to change that to 5. Okay. So now I'm going through and I am going to continue at I equal to 1. I increments to 2. That's a 4, so it passes. Increments to 3, that's a 5. It goes on. Increments to 4, that's a 5, moves on. Increments to 5, that's a 4, moves on. Increments to 6. Is that right? I think so. Anyone find it in the chat yet? Nope, not yet. No one's found the error. Increments to 6. Last 3 equals 0. So it's going to move in. J is going to start at 3. Which is 5. 0, 1, 2, 3. Yeah, which is a 5. Am I having a problem because I have duplicates? No, I shouldn't have a problem because I have duplicates because I'm switching that out. I cannot find this error even with a trace. I'm going to leave this one. I'm going to go ahead and leave you guys there. We are now an hour and 20 minutes from our exam. Hour and 21 minutes and 38 seconds. 7-6. I'm going to leave it here. Few things I want you guys to do before the exam. We have an hour. So I want you to spend about 20 minutes of this hour and 20 minutes continuing to go through coding bat problems. Find some easy ones. Get some easy wins. Get some just simple problems going. Go to like the warm-ups and just practice the warm-ups. Quick Java. Get those going into your fingers. Get Java into your fingers. Not necessarily something that's so hard that you're struggling and racking your brain. Get easy problems into your fingers. Do them quickly so that you're feeling comfortable writing code and you have those problems, those wins under your belt. It's a good psychological boost. Then what I want you to do is I want you to take a moment, get a snack, drink some water, go to the bathroom, take a walk around the block, take half an hour, and just decompress for a minute, okay? And that should take you to about 12:30. And then at 12:30, go ahead and click on your e-ticket, get signed in, get ready to go, get all of your ducks in line, answer the questions, answer the code of conduct, and sign all the paperwork and do all that stuff so that you're ready to go. And then go back to Coding Bat. And if it doesn't take you the full hour to get in, take a couple minutes, go back to Coding Bat, do a couple more of those warm-ups. Then about 5 or 10 minutes before the exam starts, make sure that you're ready to go. If you need a glass of water, if you need scratch paper on your table, make sure that you have all of that set up before. Have it all ready to go. If you need to use the bathroom, use it one more time. You do not want to have to get up during the exam. And then sit there and wait. In those last couple minutes, just take some deep breaths. Close your eyes and meditate or stare off into the distance. Just take a couple minutes and breathe and relax before the exam. But make sure you are on the exam page, because as soon as the time clicks over, you want to be doing that. You don't want to be on Coding Bat. You don't want to be doing something else. You don't want a whole bunch of tabs open. You want to be on that exam page waiting for it to automatically refresh and get you into the exam. Unless there are any other questions, I wish all of you the best of luck. Again, remember that this is not a referendum on who you are as a person. This is just a single exam, a single snapshot in time of your current knowledge of Java. And even then, it's really about your current ability to solve just a couple of short questions, not really your ability to be a great programmer. I have no doubt that many of you, all of you, in fact, will be very successful in your lives, whether or not you score 5s or 4s or 3s or stars on this. It has been my honor teaching you guys. Next week, I will have something fun. I wish you all the best. Really, I do. And I hope that we all score 5s, not just for my own ego, but also for you guys. I really want you to do well. Okay, good luck, everyone. I will see you on the other side. I'm going to post in Canvas, I'm going to post up a discussion page that we can talk after the exam, and you guys can vent and discuss the whole exam up there. Okay, good luck. Bye, everyone.